Questions 31 through 36 on the Algebra EOC. The first one gives us this equation where P equals this binomial minus this monomial. It's telling us to rearrange this and just consolidate the variables because there's only one constant in here, right? And if you look at the words, what this thing is trying to tell me is that y is my input and p is my output. P is a function of y, which is a little confusing because normally x is your input, but it doesn't matter. You can call your horizontal whatever you want to. But it's just saying that the number of paintings I sell will result in a profit of something. Okay, so what I got to do here is I got to get rid of the parentheses. There's a positive 1 in front of that one. It's invisible, so I have to just multiply everything by positive 1, which doesn't change anything. So it's 200y plus 23.25. Then there's a negative 1 in front of this thing, so I have to multiply everything by negative 1 inside of here. So it's going to be minus 10.53 y. Right, so my y values are right here, and those are the only terms that are alike, so I can combine those. And then my constant is all by itself, so I need a y value and a constant, so that eliminates this one, eliminates that one, because this one doesn't have both a y value and a constant, so it leaves me with this one and this one. Well, this is 200y minus 10.53, so it's going to be something less than 200y, so it's got to be that. Right, so where 23.25 is my y-intercept, and then I'm going to make, that's how much money it starts with, right, and I'm going to make that much money, that much profit, $189.47 per painting that I sell, right. The delta here, this delta, this change in y is consistent, and each change in y is 189.47. But there's that, so that's the answer. You can see that 200 minus 10.53 is indeed 189.47. So there you go. There's that one, pretty straightforward. Okay, here's one where it has a bunch of words to just tell you to rearrange this equation and solve for v. Right, so if this is the same thing as d equals vr, because the multiplication sign is just the dot. Got to divide both sides by the thing that is preventing the variable that I want to be by itself. So this is v multiplied together by r. To separate multiplication, I need to divide. So the r's go away, so v equals d divided by r. Another way to look at this is d over 1 equals vr over 1, and the variable that I need to move is right here. If it's on the numerator over here, it becomes on the denominator over here, and I get the same answer, so v equals d divided by r. Okay, here's two divers that are underwater, and it's the absolute value of a minus 32, or x minus 32 equals 11. Recognize that there's an invisible a here, and it's 1, right? So if I needed to get rid of this before I do the next step, I have to have just the absolute value bars on one side and whatever's inside of them, and then something else on the other side. So I have to divide by a, but that's not the case here because a is just 1, right? So I already have it set up so that I can just clear the absolute value bars. So to clear the absolute value bars, it's x minus 32 equals 11. You got to move the absolute value bars to the other side. So x minus 32 equals the absolute value of 11, meaning that x minus 32 equals 11, and x minus 32 equals negative 11. So now I got to move this 32 to the other side. If it's opposite, if it's negative 32 on one side, it's positive 32 on the other side in both occasions. Right, so this is going to be 11 plus 32, which is 43, and it's going to be negative 11 plus 32, which is going to be 21, I believe. 11 negative plus 32 is 21. Yep, so 43 feet and 21 feet, and that's how far they are away from each other. Okay, here's an equation. This one is linear because it says it's linear. And I can see that it's linear because x, there's nothing fancy about x, it's just x, it's not x squared. the x isn't the variable in the exponent. So there's that one. The other one is this one, and doesn't tell me. Oh, table of linear functions are. Okay, this tells me it's a linear function as well. All right, so I got to figure out the slope here. So the slope in this one, this is y equals mx plus b. That is the slope. And this is the y-intercept. Over here, I have the y-intercept because when x is 0, y is the y-intercept. So this y-intercept is 0 and -2. This y-intercept is 0 and -1. Okay, so this one is asking me about different things. Lesser x-intercepts, lesser x-intercept, greater x-intercept, greater x-intercept. So I can eliminate 2 of these right now because I know that on a number line, I guess we can do it in y. We'll do it in the y direction. In a number line like this, right, where this is infinity, this is negative infinity, this is 0, right? I have my purple one, which is right here at -2, and then I have my other purple one, which is a little bit more purple. I guess that's burgundy and then purple. So this is -1, this is -2, -1 is greater than -2. All right, so the r function, the q function is greater, so q is greater than r. Also, r is less than q. That's 2 similar things, right? So function r has a lesser y-intercept. That is true. Function r has a lesser y-intercept. Okay, so we're looking for a lesser. Function r has lesser, so it's not these ones because function r has a lesser y-intercept. And then we got to figure out which one is the slope. So I don't know the slope for this one. The slope for this one is 2. What's the slope over here? Well, the change in x here is 1. And I can go from here to here. It changed by 4. It went up 4. No, it didn't. It went up 6. Went up 6. From here to here, it went up 6. From here to here, it went up 6. Also, like you could also have done, well, 6. From here to here, it changed by 18. By 18, and it went from 0 to 3, so it's 6. Right, so 6 over 1 is 6, or 18 divided by 3 is 6. My slope is 6. So the one equation looks like, let's see, so my purple equation starts at -1, and it has a slope of 2 to 1 to slope. And then my burgundy equation starts at -2, but it has like a 6 to 1 slope. Okay, so the 6 to 1 slope is greater, is actually 3 times greater, because 6 divided by 2 equals 3. So, and a slope is 3 times greater, right? So there we go, that's the answer. Okay, so that was pretty straightforward if you know how to figure out slope. Okay, so now I have these 2 systems of equations. Okay, and the first thing that I can do is look at the differences right away. Okay, the first difference that I see is that x is less than 5 and y is greater than -3, but it's not just less than 5, it's less than or equal to, right? That or equal to sign means that for my x, I'm gonna have an up and down value that is solid, because that up and down value identifies the x, right? Because if this is my x-axis, I have an up and down value that locks in some number of x. Okay, and the y value, so it's a solid line. Okay, so now I'm looking for up and downs that are solid. So this one is solid, that one is solid, this up and down is not solid, that up and down is not solid, so it's not that one. Okay, and my y does not have, so when it marks y like this, it's not going to be a straight line, it's gonna be a dotted line, y, right? So y gets marked with a dotted line. So I got my y-axis going up and down. My y gets marked like that, saying, hey, this is my y value. Okay, so now it's like, okay, well, x has to be greater than, it has to be both of these, and it's got to be both of these. So x has to be greater than 5, right? So over here, my x is greater than 5 right here. But if I go over here, my x is not greater than 5 over here. My x is, actually it is greater than 5, because x is right here, x is greater than 5 here, and it's greater than 5 right here. Okay, but I also have to include my y value, which is less than -3. Right, so right here, my y value is -3. This one doesn't show, there, right there, -3 is right here, but this is all -3 right here, but the only thing that includes both of them is this one, so it's A. Right, another way to check this is, you could use the test value here. Let's put in like a point right here. Okay, and okay, let's test that. My x value for that is 8. So 8 is 8 greater than or equal to 5. Yes, it is. It's true. And then here is my -4. -4 is y is -4 less than -3. Yes, it is. It's true. So this is where the area of the coordinate plane satisfies both these requirements. Okay, so hopefully that helped, and we'll be moving on to the rest of them here soon.